At 7:17 in the morning on June 30th, 1908, something streaked across the sky over central Siberia. Witnesses hundreds of miles away described a column of blue-white light, brighter than the sun, moving almost horizontally across the horizon. Then it exploded. The blast released energy estimated between 10 and 30 megatons of TNT, roughly 1,000 times the yield of the bomb dropped on Hiroshima. 80 million trees were flattened across an area of 830 square miles of taiga forest. The shockwave knocked people off their feet 40 miles away. Seismographs across Europe registered the impact. Barometric pressure sensors in England detected the atmospheric wave twice as it circled the entire planet. Nothing hit the ground. There was no crater. Whatever it was, it detonated in midair. And for over a century, we've been trying to figure out what it was. The explosion occurred over the Podkamenaya Tunguska River, a sparsely populated region inhabited primarily by the Evenki, an indigenous nomadic people. Because of the remote location, there were no immediate casualties recorded, though Evenki oral histories describe herders being thrown from their feet and tents being blown away. The nearest Russian settlement was the trading post of Vanavara, about 40 miles from the epicenter. Witnesses there reported a flash of light followed by a sound like artillery fire. One trader, Semyon Semyonov, later recalled, "The sky split in two and fire appeared high and wide over the forest. The heat was so intense I felt as if my shirt was on fire." Hundreds of miles further away, the Trans-Siberian Railway passengers saw the flash. In Irkutsk, roughly 550 miles distant, seismographs recorded what they initially classified as an earthquake. But the most striking effect was visible across Europe. For several nights after June 30th, the skies over Britain, Scandinavia, and Western Russia glowed with an eerie, silvery luminescence. People in London could read newspapers outdoors at midnight. These were likely noctilucent clouds, ice crystals in the upper atmosphere, scattered by the debris plume. The energy release was staggering. Modern analysis has refined the estimates, with most researchers settling on approximately 12 megatons, roughly equivalent to the yield of the largest U.S. nuclear weapon ever tested in the atmosphere. The shockwave registered on seismometers as far as Jena, Germany, over 3,000 miles away. The atmospheric pressure wave was detected by barographs at stations across Europe, including one in Potsdam that recorded it passing twice, once going east and once returning from the opposite direction after circling the globe. Trees were flattened in a distinctive butterfly-shaped pattern radiating outward from the epicenter, with a peculiar feature at the center. Directly beneath the blast, trees remained standing, but were stripped of all their branches, left as bare poles pointing straight up. This pattern is consistent with a downward-directed shockwave from an airburst, an explosion occurring several miles above the ground. The butterfly pattern, rather than a perfect circle, suggests the object was traveling at an angle, entering the atmosphere from the southeast and detonating while still in motion. Despite the scale of the event, no scientific expedition reached the site for 19 years. Russia in 1908 was on the brink of revolution. The region was extraordinarily remote, and frankly, an explosion in the uninhabited taiga was not a priority for a crumbling empire. In 1927, Soviet mineralogist Leonid Kulik organized the first scientific expedition to the epicenter. He expected to find a massive impact crater and meteorite fragments, a discovery that would bring prestige to Soviet science. What he found shocked him. The devastation was total. For miles in every direction, trees lay flattened on the ground, all pointing away from a central point. But at that central point, nothing. No crater, no rocks, no fragments. Kulik conducted 3 more expeditions through the 1930s. He drained a nearby bog, thinking it might be a filled-in crater. He drilled into the permafrost. He searched systematically for meteorite fragments. He found nothing extraterrestrial. He was convinced the answer was buried somewhere in the swampy ground. He died in a German prisoner of war camp in 1942, never having solved the mystery. The absence of a crater is the defining puzzle of the Tunguska event. Every known meteor impact of comparable energy has left a crater. The Barringer crater in Arizona, formed by an object releasing roughly 10 megatons, is 3/4 of a mile wide and 560 feet deep. Yet at Tunguska, Nothing. This led to the now accepted explanation, an airburst. The object, whatever it was, exploded at an altitude estimated between 5 and 10 kilometers above the surface. It never reached the ground. The blast wave propagated downward and outward, flattening the forest, but no solid material impacted the surface. Airbursts are not theoretical. On February 15, 2013, a 20-meter asteroid entered the atmosphere over Chelyabinsk, Russia, and detonated at an altitude of about 30 kilometers. The explosion released approximately 500 kilotons of energy, about 30 times less than Tunguska, and still shattered windows across 6 cities, injuring roughly 1,500 people. The Tunguska object was likely 50 to 80 meters in diameter. The Chelyabinsk object was 20 meters. The difference in energy is not linear, it's cubic. A slightly larger rock produces a vastly more powerful explosion. So what was it? An asteroid or a comet? The distinction matters. An asteroid is rock and metal. A comet is ice and dust. If a comet exploded in the atmosphere, it would leave virtually no surviving fragments. The ice would vaporize completely. This would explain why Kulik and every subsequent expedition found no extraterrestrial material at the site. The comet hypothesis was championed in the 1930s by British astronomer Francis Whipple and later by Soviet astrophysicist Vasily Fesenkov. It fits several observations: the absence of fragments, the noctilucent clouds, which could have been caused by water vapor and dust injected into the upper atmosphere, and the bright night skies over Europe. However, more recent studies have complicated the picture. In 2013, a team led by Viktor Kvasnitsia published findings in the journal Planetary and Space Science, reporting the discovery of microscopic fragments in the Tunguska soil, tiny diamonds and Lonsdaleite crystals consistent with a stony asteroid that fragmented under extreme heat and pressure. If confirmed, this would support the asteroid hypothesis. As of now, there is no consensus. The most widely cited model, published by researchers including Mark Boslow at Sandia National Laboratories, favors a stony asteroid of about 60 meters that disintegrated in the atmosphere. But the comet theory has not been definitively ruled out. Over the decades, the Tunguska event has attracted more speculative theories than almost any other natural event. Nikola Tesla allegedly claimed, or was claimed by others to have claimed, that his Wardenclyffe Tower experiments caused the explosion. There is no credible evidence for this. The tower was never operational at the time. Others have proposed antimatter, a miniature black hole passing through the Earth, a natural hydrogen gas explosion from the permafrost, or even an alien spacecraft. None of these theories have scientific support. The antimatter theory was proposed semi-seriously by physicists Lincoln LaPaz and Clyde Cowan in the 1960s, but it would have produced a distinctive gamma-ray signature that was never detected. What is scientifically established is this: an object entered the atmosphere at hypersonic speed, superheated the air around it, and detonated with the force of a large thermonuclear weapon. Whether it was rock or ice, it was between 50 and 80 meters across, and it arrived at a steep angle from the southeast. The planet got lucky. The explosion occurred over one of the most remote, uninhabited regions on Earth. Had it arrived 4 hours and 52 minutes later, Earth's rotation would have placed St. Petersburg directly beneath it, a city of nearly 2 million people in 1908. Here's the unsettling truth about the Tunguska event. It will happen again. The question is not if, but when and where. NASA's Center for Near-Earth Object Studies currently tracks over 34,000 near-Earth asteroids. Of these, roughly 2,300 are classified as potentially hazardous, but objects the size of the Tunguska impactor, 50 to 80 meters, are extremely difficult to detect before they arrive. The Chelyabinsk asteroid in 2013 was completely undetected until it hit the atmosphere. Current planetary defense efforts, including NASA's DART mission, which successfully deflected the asteroid Dimorphos in 2022, are designed for much larger objects detected years in advance. A Tunguska-class object on a collision course could arrive with days or hours of warning, or none at all. In 1908, the blast flattened empty forest. The next one might not land in an empty forest. The Tunguska event isn't just a mystery, it's a warning. and the sky doesn't issue those twice.